All right, so if you guys can turn to page 48 of your packet, I'd like you to try out page 48, 49, and 50 on your own. And I know these formulas right here are not on the top of the page. I put them here just so you don't have to keep flipping back and forth. But I'd like you to try out 96, 97, and 98 on your own. And remember, we're skipping the last part of each question, and then you could check your answer with my video. Okay, so on number 96, we're just doing part A and B. So part A says to write a function for the temperature of the cup of coffee T in Fahrenheit as a function of time lowercase t in minutes. So they want us to write a function of T in terms of lowercase t. So we're going to write T of T equals. Okay, now based on what they give us, right, we know that T sub A is the ambient temperature or the temperature of the surroundings. So since we're taking this heated cup of coffee and we're placing it into a room where the temperature is 68 degrees Fahrenheit, this 68 is going to be the temperature of our surroundings. So I'm going to put that right here. And then we're going to have plus, and then in parentheses, T sub 0 is the initial temperature. So the temperature of the coffee, when it was first heated, it started off at 194 degrees. So that's going to go in the initial spot. And then I'm going to write minus, and remember, T sub A is equal to 68. That's the temperature of the surroundings, the temperature of the room where we're putting it. Okay, and that's going to be times E to the negative. Now in place of this K, they tell us K is 0.2581. And then I want to leave it in terms of lowercase t for time. Right, remember, if this is a t, this is a t. This is the temperature in terms of time. So they want us to write a function. That way we could use that function for part B. Okay, so part B says how long, so that tells us we're looking for the time, we're looking for the little t, to the nearest tenth of a minute will it take for the cup of coffee to reach a temperature of 100 degrees Fahrenheit. All right, so we're going to plug this 100. We want to know how long it will take for it to reach 100 degrees. So remember, T of T stands for the temperature after a certain time. So I'm going to replace this, T of T, with the 100. And then I can just bring down the rest of this equation. And remember, what we're doing is we're solving for T. Okay, we're solving for, I should say, lowercase t, right? We're solving for the time. And once you get the hang of these, I mean, you solve these the same exact way every time. You follow the same steps. Okay, so we know the first thing we do is we get rid of this 68 that's hanging out all by itself right here. So 100 minus 68 is 32. So we have 32 equals, now, I mean, I might as well combine these, right? 194 minus 68 is 126. And let's just bring down the rest of the equation. Okay, then we're going to divide both sides of the equation by 126. And 32 divided by 126, if you want to simplify that, that fraction simplifies to 16 over 63. Okay, and on the right side of the equation, I'm left with e to that power. Okay, now, since we have the e all by itself, this is where we want to put ln in front of both sides of the equation. All right, so on the left side, I'm left with ln of our fraction equals, and then ln cancels with the e, leaving us with negative 0.2581t. And to get the t by itself, we could divide both sides by that decimal in front of the t. Right, so these cancel, and you're literally just plugging this in your calculator exactly like you see it. And when you do, let's see, they want us to round to the nearest tenth, so one decimal place. That gives us 5.3. And then our units would be minutes. By the way, that's a kind of sloppy 5. Let me just rewrite that in case you can't see that. Okay, so that was supposed to be a 5. Okay, so that is our answer for number 96. Okay, so 97. I just put the formula at the top of the page here so we could see it. So, I'm looking at part A. It says determine the decay constant K. So we know we're solving for the K. So that means we need to plug in numbers for everything else. All right, so as we read through, we're just going to plug in our numbers where they go. I kind of just set up the format real quick. So it says, suppose a frozen package of hamburger meat is removed from a freezer that is set at 0 degrees. So when we first remove it, when we initially remove it, the temperature of that frozen hamburger meat is 0 degrees. So that's going to go in for the initial temperature, T sub 0. Okay, so 0 is going to go right here. All right, and placed in a refrigerator, so this is the surrounding temperature I'm placing there. I'm placing in a refrigerator that's set at 38 degrees. So 38 degrees is the temperature of the surroundings. So 38 is going to go in for the T sub A's. Okay, 6 hours. So 6 hours is our time. That's going to go in for the little t for time. Let's put a 6 right in here. 6 hours after being placed in the refrigerator, the temperature of the meat is 12 degrees. So this is the temperature after a certain time has passed, which we know is our T of T. So I'm going to replace that with a 12. Please do not think that means T times little t. This is the temperature in terms of the time. This is all one number, so that all gets replaced with a number. All right, now we're just going to solve this. Okay, so I'm first going to subtract 38 from both sides of the equation. So 12 minus 38 would be negative 26. Oop, my pen's not working here. Here we go. And then right here, 0 minus 38 is negative 38. So I'm going to bring down negative 38 e to the... Now, instead of writing negative k6, isn't that just negative 6k? Isn't that normally how we would see it? So I'm going to write negative 6k power. All right, so we want to get the e by itself, so I'm going to divide both sides by the number in front of that e. And a negative divided by negative is a positive, right? And 26 divided by 38, if you could do that in calculator and hit math, enter, enter, or it would just simplify to positive 13/19, right? So a negative divided by a negative is a positive, and that simplifies to 13 over 19. And then the negative 38's cancel, so I'm going to bring down the e to the negative 6k. Now that we have e by itself, I'm going to put an ln in front of it so I can get rid of it. And if I put an ln in front of the right side of the equation, I also have to put it in front of the left side of the equation. So that's going to leave me with ln of 13 over 19. Sorry, it's an ugly 3. Equals, and then the ln of e cancels, leaving me with negative 6k. Okay, so to get the k by itself, we just divide both sides by negative 6. Okay, so it says to round to the nearest thousandth, so 3 decimal places, so you could plug in your calculator ln of 13 over 19 divided by negative 6. And when we do, we get k equals 0.063. All right, so there we have it. Part B says to write a function for the temperature of the meat, T, in Fahrenheit as a function of time, little t, in hours. Okay, so the temperature in terms of the time is going to be equal to, it's still your surrounding environment was 38 degrees. The initial temperature was 0, so none of this is going to change. So we could write 38 plus, and then parentheses, 0 minus 38. And we could bring down the e. And don't forget the formula has a negative, so don't forget that negative. Now, instead of writing k, can't we replace the k with what we found it to be in part A? So 0.063. And in terms of t, right, little t, we're going to leave it as a little t because they want it in terms of t hours, so they want a little t. So these should both be little t's right there. Okay, so that's what they were looking for in part B. There's our function. Now, most likely, we're going to use that function in part C. So let's see what it says. How long will it take the meat to reach a temperature of 32 degrees? Yeah, so we're looking for how long. We're looking for the time. Will it take for the temperature, this left side of the equation, to be 32 degrees? So let's replace T of T with a 32. Okay, number 98. So in part A, they want us to write a function for the temperature of the meat, T, in terms of the time, lowercase t, just like all the rest. All right, so let's take a look at what we have here. Okay, so I kind of set up my equation, right? We know we're going to have T of T, and we know we're going to have a little t up here. So we need to plug in numbers for the K, the T sub 0, and the T sub A. So let's read. A frozen package of hamburger meat, well, this is kind of similar to the last one, right, is removed from a freezer that is set at 0 degrees. All right, so this is the initial temperature, so we're going to plug in 0 for the initial. So that's T sub 0, right? T sub 0 is the initial. Okay, it's placed in a refrigerator that is set at 37 degrees. So the refrigerator, right, is the temperature of the surroundings, the T sub A. So we're going to replace that with 37. Okay, the temperature of the hamburger meat is changing such that its decay constant, K, is, and they tell us the K. So let's plug that in for the K. So 0.1096. And again, don't forget about that negative built into the formula in front of us. So that's all they're looking for part A. Okay, part B, how long to the nearest hour? So we're looking for the time, right? How long? We're looking for the time, the little t, will it take for the meat to reach a temperature of 32? So we're going to replace T of T with 32. So we'll have 32 equals, and you could just bring down the entire right-hand side of the equation. All right, so again, we're solving for an exponent, right? We're solving for the little t. So we use the same process. We first subtract this number that's in the front, the 37. So that'll give us negative 5 equals, and then 0 minus 37 is negative 37. E to the negative 0.1096 t power. All right, so now let's divide by the number that's in front of the e. And since we know a negative divided by a negative is a positive, and then 5 over 37 doesn't simplify, let's just rewrite it as positive 5 over 37. That's going to be equal to e to the negative 0.1096 t power. All right, now that we have this e by itself, we know we have to put ln in front of both sides of the equation. So that'll leave us with ln of 5 over 37 equals, and the ln and e cancel, so we could bring down the negative 0.1096 t. So we get the t by itself, just divide by the number that's in front of the t. All right, so we're just plugging in our calculator, ln of 5 over 37 divided by negative 0.1096. And when we do, let's see, they want us to round to the nearest hour. All right, so that rounds to, I'm getting 18.262. So the nearest hour, that would be 18 hours. All right, and there we have it.